So the next category of problems is integration by parts. You can write this down. Integration by parts. Okay. So the formula is integration of u into v dx. U integration v dx, bigger integration, dy dx of u, integration v dx bracket close dx. Okay, this is integration by parts formula. The formula might seem to be difficult right at the beginning, but then it's very easy. Okay, after the end of the class, you'll just find it to be easy. Don't worry about it. Okay, so u into v. Okay, it follows a certain rule which is called as LAE rule. LAE rule, where L is logarithmic functions, A is algebraic functions, x raised to n. A is algebraic functions, x raised to n. Okay, E is exponential function, e raised to x, a raised to x. It follows this rule. This bigger integration should look like bigger integration. Box bracket should be there, should be there. Okay. Now in integration, there is no product rule or quotient rule. Product rule or quotient rule is there in derivatives. Integration does not have product rule and quotient rule. Okay. So right now we'll just work on this particular formula. Fine. Yeah. A simple problem I'm going to take. Exercise 5.5, question number 1. Question number 1. Integration of x log x. Now LAE. X is algebraic because x in the base power is 1, x raised to n. So x is algebraic. Log x is logarithmic, obviously. So the order is not right. Logarithmic term should be first. Look at this priority list. LAE rule. It should follow that rule. First term should be logarithmic. So I'll just interchange this. Log x into x. I reversed it. So this will be u and this will be v. The first term will be u and second term will be v. If you take this as u, if you take this as v, you will get a wrong answer because it is not following this rule. As per this rule, logarithmic term should be first and then algebraic. Now after this, I'll just write down the formula. Formula should be written very precisely. No shortcuts. Make use of space. So this formula has derivative as well as integration. Log x is u, v is x, v is x. D by dx of log x, v is x, v is x. Okay. What is the integration of x? I've given you as a formula. Please tell me.
X square upon 2 plus
Correct. X square upon 2 because x is x raised to 1. So x raised to n plus 1 upon n plus 1. The integration of x is x square by 2. Just copy till here. I'll just Wait for you. So log x into x square by 2. Bigger integration. Box bracket. Don't leave the box bracket. Box bracket d by dx of log x is, anyone?
1 upon x.
1 upon x. Correct. And what about this part? This particular part? Solution of this.
X square upon 2 plus c.
Correct. X square upon 2. Bracket close dx. Plus c will write towards the end of the problem when all integration signs are gone. X square log x upon 2. Half outside. X square upon 2 is x. Again, integration of x is x square by 2 plus c. X square log x upon 2 minus x square upon 4 plus c. Copy. Final answer this. Are you done with this?
So 1 second.
Sure.
Yes, sir. Thank you.
Second problem. Prior to that, any feedback? Have you understood this?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Question number 2. Integration of x square e raised to 4x dx. LAE. Algebraic exponential. X in the base, algebraic, x in the power, exponential. Do we need to interchange this? Reverse this? Yes or no?
No, sir.
No, sir.
Because it follows the order. First algebraic and then exponential. So this is u and this is v. Write down the formula very clearly. It's very simple, believe me, guys. U is x square e raised to 4x dx. dy dx of x square e raised to 4x dx, bracket close dx. Now we are going to make a working note over here because this part we are going to solve again and again in the problem. E raised to 4x dx. What is the integration of this?
E
What is the
raised to
integration?
x plus c.
E raised to x integration is e raised to x. So e raised to 4x integration is what?
You take d by dx 4 in the denominator of 4x.
Perfect, perfect. Upon d by dx of 4x. Okay. And then this is going to be e raised to 4x plus 4 upon 4 plus c. Okay. So this working note you write only once, so that again and again whenever you see this, you don't have to write all these steps. Anyone has any problem in the working note, this particular part?
No, sir.
Great. Okay, what is the derivative of x square?
2x. 2x.
2x. Don't leave the box bracket. Bigger integration should look like bigger integration. What is 2 upon 4?
1 upon 2.
1 upon 2.
Where that 1 upon 2 will go?
Outside the integration.
Perfect. So x square e raised to x by 4 minus half x e raised to 4x dx. Now guys, tell me how to tackle this. How to tackle this? Anyone with any guesses?
You
Tell
take
me.
it again. LA rule.
Again UV, correct. Perfect. Because the first term is algebraic, x is algebraic, x is x raised to 1, x in the base. E raised to 4x is exponential, so this is u and this is v. Okay, so after half we are going to put a curly bracket and solve this. Okay, if you have copied this slide, if anyone's still copying, just let me know. I'll wait. Otherwise, I'll go to the next slide.
1 second, sir.
Yeah.
Done, sir. Thank you.
Okay, so I'll just tell you what should be the nature of steps. X square. Okay, now here again you are going to apply that formula. Now put the new values of u and v. U is x e raised to 4x dx, bigger integration, d by dx of x, curly bracket should close. Every opening bracket should have a closing bracket. D by dx of x is 1. What will I do with this 1 by 4? 4
Take it outside the integration.
Correct. Within the curly bracket. Now this is the last step which is pending. So we have to write this now. And at the same time, okay, that we'll do later. But then first integrate e raised to 4x. That is e raised to 4x by 4. That we have already done. Directly you can write e raised to 4x by 4. And showing that working note is very important. So x square e raised to 4x by 4 minus half x e raised to 4x by 4 minus 1 by 4 e raised to 4x by 4 plus c. See this part, the only thing changing in this step is this particular part. I'm just writing this as e raised to 4x by 4. I'm integrating it. Now we'll just open the bracket and complete the problem. X square e raised to 4x by 4 minus x e raised to 4x by 8 plus e raised to 4x by anyone? Anyone?
16. No.
32. 4 4s are 16 into 2, 32. Okay. Next problem. Now this is an extra problem. And mark this problem as very, 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 very important. Because this problem is going to create a base for many other problems. Okay. So the problem is integration of log x dx. Integration of log x dx. Okay. Now we have the derivative of log x, that is 1 upon x, but then there is no integration of log x. There is no formula. So this can be written as log x into 1 dx, u into v. So whenever logarithmic term is a single term and they're asking to integrate, v will be always taken as 1. You have to remember this. Now the problem is very simple. U integration v dx, dy dx of u, v dx, bracket close dx. Put the values. Put the values of u and v. What is the integration of 1?
X plus C.
Integration of 1 is x. Correct. So log x into x. Next step. Minus d by dx of log x is 1 upon x. I've written this d by dx of log x is 1 upon x, and this one is x. Okay. I'm just writing this as x log x. You cannot multiply this x and write x square. Okay. Cancel this x because there is multiplication. What is integration of 1, guys? Because we are left with this. What is integration of 1?
X plus C.
X plus c. Integration of 1 is x plus c. That is the answer. Exercise 5.5, question number 3, you can take it for self-study. New property. Integration of e raised to x, f of x plus f dash x dx, e raised to x, f of x plus c. Example, e raised to x log x plus 1 upon x. Now there is e raised to x in the problem. Within the bracket we are having f of x, and within the bracket we are also having 1 upon x. Plus sign is there in between. Can we apply the property? Can we apply the property? Yes or no? Yes or no?
Yes.
So this is e raised to x f of x as per the property. F of x is what? Log x. F of x is log x. This was an extra problem along with that property. Please copy this. The function and its derivative is present within the round bracket, and e raised to x should be there. Then only we can apply this property. Next problem. Exercise 5.5, question number 5. Integration e raised to x 1 upon x minus 1 upon x square. E raised to x is there in the problem. See how I am writing. Just think. What is the derivative of 1 upon x?
Minus
What
1
is it?
upon x square.
Is it present in the problem?
Yes, sir.
Yes. So I'll just put a plus sign in between. Okay, because the property requires plus. Is this and this mathematically same?
Yes.
Because plus into minus is this minus, which is given in the question. We are putting that plus sign in between to apply the property. Okay. Now, guys, what is this? Anyone? What is this? What is 1 upon x?
F of x.
F of x.
And what is minus 1 upon x square?
F dash x.
F dash x. Okay. E raised to x, f of x plus c. E raised to x, 1 upon x plus c. E raised to x, 1 upon x plus c. Any doubts or clarifications required in this problem?
No, sir.
Question number 8. Integration e raised to x log x the whole square 2 log x upon x. So let f of x be log x the whole square. F dash x is the derivative of this. Chalo, let's derivate this. Now derivatives, you know. Which formula to apply over here? Which formula to apply over here? Which formula to apply over here?
X raised to n.
X raised to n. So n x raised to n minus 1. So if you're comparing this with x raised to n, who is your x? Who is your x over here?
Log x.
Log x.
So dy dx of log x, and we are writing this dy dx of log x in the numerator because this part is derivatives, not integration. Okay. So 2 log x into 1 upon x. Dy dx of log x is 1 upon x. 2 log x upon x. Now you guys tell me, is this f of x and is this f dash x with a plus sign in between?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So the answer of this will be e raised to x f of x plus c. Put the value of f of x. F of x is log x the whole square.